Hi guys, here's our review for Unit 1. Sorry about my voice, I'm a little bit sick. But yeah, let's get started. So, question 1 says, determine the mean, median, mode, and range of the following. So, we have the heights in inches of 10 high school varsity basketball players are 78, 79, 79, 72, 75, 71, 74, 74, 83, and 71. So we have to calculate the mean, median, mode, and range. So just so you remember, mean is when you add up all the numbers and then you divide by how many they are. So you would do 78 plus 79 plus 79 plus 72 plus 75 plus 71 plus 74 plus 74 plus 83 plus 71. And then you would divide that total by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 because we have 10 numbers. Your median is when you first arrange the numbers from least to greatest and then you take one off from each end until you get to the middle number. Mode is the number that's repeated the most times, or the most frequent number in the data set. And range is your largest number minus your smallest number, or your max minus your min. So we can calculate everything by hand, but just remember that your calculator can help you out with that. So let's go ahead and do it in the calculator. So what you want to do is you go to Menu, Stat, hit enter, and then you should have a clear list. If you don't have a clear list like this, you're going to go to the number and then you hit delete, delete, delete until it's clear. Once your list is clear, you're going to go ahead and enter in all the numbers in the data set into your calculator, and you don't need to organize it. The calculator will arrange it from least to greatest for you. So we have 78, 79, 79, 72, 75, 71, 74, another 74, 83, and 71. After you entered your last number, above F2 on your calculator, you should see calc. You're going to hit F2 for calc, and then you're going to hit F1 for one var. If you didn't see calc above F2, you're going to hit exit, exit, exit until you see it. Once you see calc above F2, you're going to go ahead and hit F2 and then F1. And then your calculator should bring up all the one variable statistics. The first number on your calculator, X with a bar on top, like so, is your mean. So here, our mean is equal to 75.6. And that's it. If you scroll down in your calculator, you should see MED. That's your median. So your median here is 74.5. And then if you look in your calculator under max, we have MOD. That's your mode. So your mode here is 71 because 71 is repeated 2 times in our data set. Alright, cool. And then the last part is the range. Our calculator doesn't give us the range, but it gives us the max and the min. So we know that our range is the max minus the min, which is, from our calculator, 83 minus 71. Which should give us 12. So our range here is 12. And that's it for question 1. Alright, cool. Question 2 says, classify as rational or irrational. So you can look through your notes again for all the notes on rational and irrational. But just so you remember, a number is rational if it can be written as a fraction. And a number is irrational if it cannot be written as a fraction. And then there are other stuff like if you have a perfect decimal, that would be rational. If there is a decimal that's repeating with a pattern, that's rational. If you have a decimal that's really messy and crazy and goes on forever and there's no pattern, that's irrational. All right, so let's look at these numbers. So we have 0.13. That's a nice, neat decimal. So 0.13 would just be rational. Then we have 3.456. That's also not a crazy decimal, so that would also be rational. Then we have 0.3 with this line on top, right? So remember, when we have a line on top, that just means that this 0.3 is going on forever, right? Or 3 is being repeated, right? And since it's being repeated in a nice pattern, then 0.3 repeating would be rational. 89 is a nice whole number, so that would be rational. 2/5 is already a fraction. Remember, if something can be written as a fraction, it's rational, so 2/5 is rational. -30/4 is also rational. It does not matter if it's negative or positive. If it can be written as a fraction, it's definitely rational. Then we have 0.6 with the line on top. That's a repeating decimal, so 0.6 would also be rational. We have radical 5. So if you're not sure whether the square root can be simplified perfectly, always double check in your calculator. So you're going to hit shift and then x squared, enter 5, hit enter. And if your calculator gives you back the same thing, then it's most likely not rational. If you hit the SD button above number 8, you're going to see that we have a messy decimal. There is no pattern here. We can't tell if it's repeating. It seems to be going on forever. So radical 5 would be irrational. If we entered radical 9, we know that the square root of 9 is just 3, right? Since that's a very nice number, it's a whole number and everything, then then square root of 9 is rational. Square root of 13. Square root of 13 is not a perfect square root. It's not a perfect square, so square root of 13 is irrational. Next we have square root of 49 plus 9. We know that the square root of 49 is 7, and the square root of 9 is 3. So this is 7 plus 3, which is just 10. So that's rational. Square root of 49 plus square root of 9. And then the last one, we have square root of 2 plus square root of 2. That's just irrational. And if you double check that in your calculator, you would see that it doesn't get simplified, and it's just a messy decimal. All right. Question 3. Which expression represents an irrational number? So we know that the square root of 16 is 4, plus the square root of 1 is just 1. This would just be 5. So this is not an answer because we're looking for irrational. We know that the square root of 25 is 5, plus the square root of 4 is 2, which is just 7. So this would not be an answer. We know that the square root of 36 is just 6, plus the square root of 7, which cannot be simplified, right? So if you check this in your calculator, we have shift x squared, square root of 36, And just a side note here, when you want to enter a second square root, you have to hit the side arrow on your calculator to get out of that first square root before you continue typing the rest of the expression. So square root of 36 plus the square root of 7. It just gives you the same thing back, and if you hit SD, you're going to see that it's a messy decimal. So our answer choice here, you can see right away it would be 3. Right? And just for reference, we know that the square root of 49 is 7 plus the square root of 9 is 3, which is just 10. So this is rational. All right, cool. What did I do? All right. Next question is asking us to calculate the mean, median, and mode from the dot plot. So when we have our mean, median, and mode from the dot plot, you know that each dot gets a point in the calculator. So we can use our menu stat to compute all of this. So you're going to go to menu, stat, hit enter. Make sure your list is completely empty, right? So here we have a 1 dot on 0. So you're going to enter 0 one time in your calculator and hit enter. Then we have 1, 2, 3, 4 dots on 1. So you're going to enter 1 4 times in your calculator. So 1, enter, 1, enter, 1, and then another 1. Each dot gets a spot in the calculator. So each dot represents a value of 1 that goes into the calculator. Here we have 1, 2, 3, 4, 5, 6 dots on 2. So I'm going to enter 2 6 times in the calculator. Then I have 1, 2, 3, 4 dots on 3. So I'm going to enter 3 4 times. I have 3 dots on 4, so 4 is going to get entered 3 times. And then lastly, I have 2 dots on 5, so 5 is going to get entered 2 times. Then we want mean, median, mode, so you're going to go ahead, you're going to hit calc, and then 1 var. So remember, if you don't see calc on your calculator screen above F2, you're going to hit exit, exit, exit. So you hit F2, 1 variable statistics, scroll down. All right. Actually, go back to the top. The first value, that X with the little bar on top, that is your mean. So here, X with the line on top, or X bar is our mean, which is 2.5. And you could see that this data is sort of bell-shaped and symmetrical, so we can guess, we could have estimated that our mean would have been somewhere around 2.5. Then we're looking for our median, so you scroll down on your calculator. MED is your median, which is just 2. And lastly, our mode is the number that's most repeated, or the value that has the most dots. So notice that 2 has the most dots, so our mode is 2. And that's it. Alright, next question, box plot. So here we have the test scores from Miss Gray's math class are shown below. We have a data set with the scores, and it's asking us to construct a box and whisker plot to display these data, and then it's asking us some interpretation questions. So first thing you want to do when you have to create a box plot is go to menu stat and enter in your data set. So I'm going to go here. I'm already in the stat, so I'm just going to hit exit, and then I want to clear out all of this data, so I'm going to hit delete, 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 delete. And then I'm going to enter the new data set. So we have 72, 73, 66, 71, 82, 85, 95, 85 again, 86, 89, 91, and 92. Once you've entered in all of your data, remember we want to hit F2 for calc and then F1 for one var. Because I was just using the calc function, it's already showing up as one var on my screen, so I could just go ahead and hit F1, right? But if you wanted to do it, if you want to practice doing it all the way, you hit exit, exit, exit. Here I can see calc above F2, so I'm going to go ahead and hit F2, and then F1. You scroll down to get your 5-number summary, and now you can create your box. So I'm just going to write down our 5-number summary on the side. We have that our min is 66. Our Q1 is 72.5. Median is 85. Q3 is 90. And our max is 95. Always write down your 5-number summary on the side of your work so that just in case your box plot is slightly off, you can get partial credit for the 5-number summary. All right, here we go. So I like to start with our Q1, median, and Q3. I like to do the quartiles first, which is the box. So I see that Q1 is 72.5. We're going to have to estimate it, so I would say that's probably somewhere around here. Next, we have our median is 85, so that's perfectly right here. And then we have our Q3 is 90, which is perfectly right here. Right? These 3 quartiles, they connect to each other to form the box of the box plot. Okay, cool. And then your min and your max are points that gets attached to the end. Which is why they call it box and whiskers, because the max and min that gets attached is the whisker. So we have that our min is 66, which is somewhere around here. So that gets a point, and then it's attached to the left end. And our max is 95, so that gets a point above 95, and then it's attached to the right end. And that's it. That's their box and whisker plot. Okay, then it's asking us 25% of the scores are below what value? So remember, each part of your box plot, right, each quartile is 25%. So they're asking us 25% of the scores are below what value? And then if you were to combine each section, from here to here is your 25% mark. From 70 to 85 is your 50% mark. And that makes sense because this is your median, and obviously the median is halfway, so that would be 50%. From 85 to 90, this is your 75% mark. And then your max is obviously your 100% mark. So then it's asking us 25% of the scores are below what value? So notice that 25% is your Q1, right? If you look over here, this is 50, then this is 75, and this is 100. Since the question is asking us about 25%, we're looking at our Q1 value. So we can say 25% of the scores are below 72.5 because 72.5 was our Q1 value. Then it's asking us the 75th percentile is, if we look at our box plot, 25 plus 25 is 50 plus 25 is 75. Or 75th percentile is always our Q3 value. So here our 75th percentile is 90 because our Q3 value is 90. And lastly, 50% of the scores are above what value? So we know that 50% is our median, and here our median was 85. So 50% of our scores are above 85. That's it. All right. Next question. Where did my calculator go? Okay. The box plot represents the distribution of speeds in miles per hour of 100 cars as they pass through a busy intersection. So here they give us the box plot, and then we're answering some interpretation questions. All right. A. What is the smallest value in the data set? Interpret this value in this situation. So we know that our smallest value is obviously going to be our min. So here our smallest value is 8. And then since we're talking about speed of cars in miles per hour, if we're going to interpret this, then it has to be in terms of that situation. So if our smallest value is 8, then we can say that our slowest speed is 8 miles per hour. So slowest speed is 8 miles per hour, right? Or one of the cars is traveling at the slowest speed of 8 miles per hour. All right, B. What is the largest value in the data set? Interpret this value. So we know that the largest value is obviously our max in the data set. And here it looks like our max is 44. So just like the one before, if we're talking about speed, then this is the fastest speed because it's our max. 44 miles per hour. All right, C asks us, what is the median? Interpret this value in the situation. So we know our median is right here, halfway, right? So here our median is 20. Now, it's asking us to interpret this value in the situation. If we're ever looking at the quartiles, so Q1, median, and Q3, if we're interpreting it, we have to interpret it as a percentile or as a percentage. We know that each part of our box plot, or each quartile, is 25%. And if you look at it cumulatively, Q1 is 25%. Q2, or the median, is 50%. Q3 is 75%. And our max represents the 100% point. So here, our median is 20. Since our median is at the 50% point in our data set, we can say that 50% of the cars are traveling either above 20 miles per hour or below 20 miles per hour, right? Because 50 is our median. It's halfway. So either you're driving faster than 50 miles per hour or you're driving slower than 50 miles per hour. So that's exactly what you want to say. 50% of the cars are driving faster or slower than 20 miles per hour. All right. D. What is the first quartile? Q1. Interpret this value. So here we know that Q1 is right here. So Q1 is 12. So when you want to interpret this, there's two interpretations you can make. You can make an interpretation going to the left side of Q1, Or you can make an interpretation going to the right side of Q1. We know here that Q1 is 12. So if I look at the left side, if I want to make an interpretation using the left side, then I can say 25%, because Q1 marks our 25 our 25th percentile. So I can say 25% of my cars are driving slower than 12 miles per hour. If I wanted to make an interpretation using the right side of Q1, I can say 25% of the cars are driving faster than 12 miles per hour. And that makes sense, because if we look at the right side of Q1, we have 25% plus 25% plus another 25%. That's equals to 75. So you can always make two interpretations for the quartiles. So it's asking us, what is the first quartile? We know that that is 12. And if we make an interpretation, we can say 25% of the cars are driving slower than 12 miles per hour, or 75% of the cars are driving faster than 12 miles per hour. I'm going to go with slower, so 25% is driving slower than 12 miles per hour. And then lastly, what is the third quartile? Interpret this value in the situation. So here we know that our third quartile is right here, Q3, which is 24. Again, we can make two interpretations. We can make one for the left side, and we can say 75% is driving slower than 24 miles per hour. Or we can say 25% is driving faster than 24 miles per hour. So our third quartile is 24. We can say 75% is driving slower than 24 miles per hour. Alright, cool. Alright, that was a lot. Alright, next question. The ages of the last 16 United States presidents on their first inauguration day are shown in the table below. Calculate the standard deviation. So for standard deviation, you want to use your calculator, because it will help you get it the fastest way. So you're going to hit exit here. You're going to go back to menu stat, and then you're going to delete everything in your list. And then we want to enter our new data set. So we have 51, 54, 51, 60. I'm just going across. 62, 43, 55, 56, 61, 52, 69, 64, and then the last row, 46, 54, 47, and 70. Alright, and then you want to hit exit, 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 hit F2 for calc, F1 for one variable statistics, and we're looking for standard deviation. So we have two standard deviations from our calculator. As you remember, we have our population standard deviation and our sample standard deviation. Most times we're going to be using the sample standard deviation, which is the SX value on our calculator. So if you look at the screen, the calculator screen, you see that SX is 7.87. So they didn't tell us what to round this to, so we're going to round to two decimal places. So we have standard deviation is equal to 7.88, because I'm rounding this to the nearest hundred. All right, perfect. Next question. Jean's scores on 5 mathematics tests were 98, 97, 99, 98, and 96. Her scores on 5 English tests were 78, 84, 95, 72, and 79. Which statement is true about the standard deviations for the scores? So, you're going to clear out your data set. And then we're going to enter in each new data set separately because I haven't taught you guys the 2 variable stats as yet. So we have that her scores on 5 mathematics tests were, let's go ahead and enter her scores for math. So we have 98, 97, 99, 98, and 96. You want to hit 1 variable stats again. Here, the standard deviation is 1.14. So, I'm just going to make a note on the corner. Math is equal to 1.14. Then you're going to hit exit, clear out this data set, and then you want to enter her scores for her English test. So we have 78, 84, 95, 72, and 79. 1 variable stats, and here we see that the standard deviation for English is 8.62. I'm rounding to the nearest hundred. And then let's see what our answer choices are saying. So we have the standard deviation for both sets of scores are equal. Obviously, they're not equal, so 1 is not an answer. The standard deviation for the English scores is greater than the standard deviation for the math scores. Yes, that's true. Here, our standard deviation for English is 8.62 and math is 1.14. So we can already say that our answer choice is looking like B. Right? Let's just double check the others. The standard deviation for the math scores, 1.14, is greater than the standard deviation for the English scores. Obviously, that's not true, so it's not C. And then more information is needed to determine the relationship between the standard deviations. Well, we already calculated it here, so it's definitely not D, which leaves us with our answer of choice B. All right, perfect. So that's part 1 of the review. I'm going to end the video here, and then I'll create another one for part 2 of the review.